And let me mute myself here. Yeah, I don't know, unfortunately, this sun is working against us, and let me turn on the light to see if it's better. I don't know, which one do you prefer? Do you think that this situation is better? You can talk me through Zoom. Is it more visible with the lights on?
Yes, a little bit.
Okay. Okay, so as you see on the title of the YouTube, this is again, I want to talk about the root equations, not talking about root equations, but I just want to bring some examples that we can solve together. That's an interesting part of actually your lesson. I would say it's good to practice a little bit about that. So I would say, write an example. Of course, you can also talk to me, because I think it would be a little bit weird if we pause. There is no pausing in live stream, of course, for the natural reasons, but if I just want to wait, do nothing, it would be a little bit weird for the people who will watch the video later. So, but you can just talk to me so that I make sure that everything is going on, okay? So I would write solve the following equations. I would say root equations. Let us keep it in brackets. It is not necessary to mention this adjective here. Okay, so let us start with, again, simple ones. So let me start with this one. Square root of 9 minus x squared is equal to square root of 19 minus 3x squared. Okay, so we want to solve this equation. So for visibility, I will try to write the solutions also in black. I think it would be easier for you to see it. Okay, so do you have any idea? First of all, let me just review a little bit. This is an equality. So, and I am looking for x. So this is definitely an equation. It contains, at least here too, at least one third sign, one square root sign. So it is a root equation. And then the only thing that you need to be careful is that when you raise, because the main strategy is to eliminate the surds, all the surds, so that you can have a normal equation and hope that you can solve that normal equation with the material that you have learned so far. And then there is only one thing that you need to be careful. It might happen that in the process of solving this equation, you get some roots that are not indeed the solution of the original equation. Because I told you that as soon as, for example, you raise both sides to power 2, you get a new equation, And raising to an even power is not a reversible action mathematically. If x is equal to 2, there is we have the guarantee that x squared is equal to 4. But if x squared is equal to 4, there is no guarantee that definitely x is equal to 2, because there is another possibility, and that might be that x is equal to -2. Exactly because of this fact, you need to be careful. This tells you that if this is going to happen, these are the numbers that you get at the end. These are the possible candidates. I would consider this a success because potentially I have infinitely many possible answers, but I will be able to narrow it down to a limited number of roots so I can test them. Yes. So I want you to understand that in principle what's going on. Okay, I think that this is very easy for every one of you. The first thing is I want to get rid of square root signs. So the enemy of a square root sign, I would say, is exponentiated with power 2, yes? Okay, and then of course this power of 2 will we will get rid of this square root sign. It becomes 9 minus x squared, and on the right hand side I will have this. Of course, you see this is a quadratic equation, and you cannot get rid of this quadratic term, but you see there is no x term. So of course you can move everything to the left-hand side, use ABC or PQ formula, but if you remember the lesson previous to ABC or PQ formula was that what happens if the x coefficient is 0? So I would solve it exactly like a first-degree equation, meaning that I move the x parts to the left and the other parts to the right. I'm telling you again, if you just move everything to the left and you solve it using ABC or PQ formula, it's okay, but I don't recommend you to do that. I want you to learn these shortcuts as well. Yes, shortcuts as well. So what I do, I move 3x squared to the left, it becomes positive. I already have a minus x squared here. And then I have 19 here. I move 9 to the right, it becomes negative 9. And then what happens here is that I have 2x squared. On the right-hand side, I will have 10. And then you know how to solve it. I divide by 2, it becomes 5. And then x becomes square root of 5, one possibility. The other possibility is negative square root of 5, yes? But I'm not allowed to put them in a box right now to accept them, because it might happen that these are fake roots. So what you need to do, you can just do it like this, for example. Let us check x equal to square root of 5. Of course, it is clear that both of them here are acceptable, yes? But let us check. Left-hand side is equal to square root of 9 minus x to the power of 2. But square root of 5 to power 2 is just simply 5, and 9 minus 5 is 4. Square root of 4 is 2. Be careful, not plus or minus 2. Always 2. And then let me calculate the right-hand side as well. The right-hand side is square root of 19 minus 3 times x to the power of 2. Yes? And then what happens here? It becomes this. Square root of 5 to the 2 becomes 5 times 3 is 15. So this becomes a 19 minus 15. Again, I get the square root of 4 and 2. So then, therefore, left-hand side is indeed equal to the right-hand side. So this means that this answer is not a false root, it's a real root. And hopefully, you really don't need to check this one again, because of this power of 2, this calculation is not sensitive to this minus sign. What do I mean by that? Because if I put minus 5 minus the square root of 5, because it's of even power, it becomes again 5. So the left-hand side for this one also becomes 2, and the left-hand side, again, because of this even power, again becomes 2. So this is also acceptable, okay? So you can just write it down. So both of these roots are actually real roots for this equation, and then these are the only ones. So that was a very simple question. Any questions so far for understanding this? Okay. Let us go to another problem. And let me write a little bit. Yeah, let us write this problem. Let us see how this will work. Number 2, hopefully we will not run into difficulty like the previous. So square root of 36 plus x is equal to 2 plus square root of x. This I will call it a high-level problem at the level of your book, for example. Yes? Why this is the case? Do you have any suggestions? How can I solve this problem? Of course, the strategy is always to get rid of certain signs. Both of them are square roots, so might be raising to power 2 might be helpful.
Get the square roots on the same side?
You mean raising to a square power, yes? Taking a square root?
Maybe get them to the same side first and then erase them.
Anyway, I would prefer exactly in this way. Of course, I don't want to force you to memorize this. We can use your method to move this to the right-hand side. Which one do you want to move?
Maybe move square root of x, maybe. I don't think it matters.
Yeah, actually it matters. Let us check that later, okay? So let us follow yours. If you say that I move this to the left, I'm not saying this is wrong, but might be you will see that this is not necessary at least. So if I move that to the right, to the left, I will face this situation, and then probably you want to raise it to power 2 later, yes? And then of course on the right hand side you don't have any problem. On the left hand side you have to use a squaring pattern definitely. So this becomes the first one to the 2, so this becomes this. The last one to the 2 is x, but you have to remember that there is a minus 2 times the first one times the second one. Okay, I'm not saying this is wrong or it's not working, but at least you see that in one step it's not possible in this form to get rid of both the square root signs, because of course this is not just 2 square root signs, because they can combine into 1 square root. So I would say this is a way to success, because first you were dealing with 2 square root signs. After this trick, at least you are facing 1 square root sign. If we want to continue this, do you have any suggestions what to do? So let me rewrite everything. This 36 is just alone. This x here and that x there becomes. But of course, if you want to continue, do you have yourself any kind of proposal? How should we continue? Anyone else? Don't lose the track, yes? What is the strategy? The strategy is to get rid of the square root signs, yes? If I want to just raise to power 2 once more, write this like this, that would be a catastrophe, yes? Because then I have to raise this one, and then again 2 times the first one times the second one will keep this square root for me. 2 things comes to my mind, yes? First of all, I see that everything here is divisible by 2, and always it is better to simplify, to work with the smaller numbers. So I divide this by 2, it becomes 18, yes? It's momentarily, but it is good. at least I am dealing with smaller numbers. I divided this by 2, divided this by 2, divided this by 2, and finally this by 2. Now what I do, for example, I move these two to the right. So I keep this one. This I expected you should be able to guess, because this is the strategy, yes. I move these to the right, so I have 2 minus 18 minus x. Okay, so it becomes minus x times 30x plus x. On the right hand side, 2 minus 18 is minus 16 minus x. And then, of course, there is a negative sign here, negative sign here, negative sign here. Negative signs are nasty things, so let us get rid of them, yes? So I multiply by a negative sign, I will get this. Positive x and positive 16. And I think everyone knows what to do now, yes? Immediately, what should I do? Square it again. And this will solve my problem. At least I am following this strategy and I will be successful, because if I raise to power 2, this square root sign will go away. This square root, this one becomes x plus 16 to power 2. Let me continue this. Let us see how it goes. On the left hand side, I can multiply. Yes, so it becomes 36x plus x squared. On the right hand side, I have to use the squaring pattern. So the first one to the 2, 2 times the first one times the second one, which becomes 32x. And the second one to the power of 2, 16 to power 2 is 256. Even though this seems to be a quadratic equation, but it is not, because if I move x squared to the left, it becomes negative and this will be cancelled out. So it means that this is just a normal first degree equation. So I move this to the left, 36x minus 32x, it becomes 4x. What is left on the right for me was 256. And then I divide by 4, it becomes 64. So this is the answer. But before accepting this as an answer, I have to go back and check that. So the left-hand side is equal to square root of 36 plus 64. But this becomes a square root of 100, and the answer is 10. The right-hand side is equal to 2 plus a square root of 64. But no, you know that a square root of 64 is just 8, and then 2 plus 8 is 10 again. Yes? So this means that left-hand side becomes indeed equal to the right-hand side, and this answer is now acceptable. So there is only one solution to this equation, and this is 64. Okay? Even though I don't myself prefer to go through this method, but it worked. So that is what I want you to understand. If you are following a set of rules, you have organized brain, you have done your homework good, so you see that this will work. Might be you cannot find the best solution, but why not? If you know what to do, and that's completely acceptable, if that is a question, A-level question with 3 points, this will bring you all 3 points. But now, I hope that you understand there was no point to moving this to the left in this problem. Might be, if you just raise both sides to power 2 immediately, it also works. So there is no point to moving it back. I want to solve this problem with that way as well, so that you can compare. Because if you really want to be a good problem solver, it's very good, it's very, very helpful and very instructive to try different methods for the same problem and understand the equivalency if the answers match. And in case the answers don't match, you need to understand why. What is the problem there? That I was thinking that this method is supposed to work, but it does not. Okay, so if I wanted to solve this, because of a little bit of experience, I didn't move this to the left and then square it. I would square it on the left in this form. So if I wanted to solve it, I square the left-hand side, so it becomes 36 plus x. I square the right-hand side, but I have to be careful. You are not allowed to write 4 plus x because you have to raise the whole expression to power 2, and that's a squaring pattern. So then what happens is 36 plus x, then it becomes 4, 2 times the first one times the second one, yes, and the second one is squared. Do you agree? Okay, but now you see that if I move these two to the left, this x when goes to the left, it becomes negative x. So this x and that x will be cancelled. When I move 4 to the left, it becomes 32. It becomes 4 square root of x. And then I divide everything by 4. It becomes 8 equals to the square root of x. And then I square it. 64 is equal to x. And of course, I have already checked that 64 is the answer. You see, it's much more quick. Yes, it's quicker to do it in this way. So even though this is not wrong, but I hope that you see this is more preferable. Yes. Do you agree with me? Yes? Yeah. Yeah, okay.
Yes.
But you see that there is nothing wrong at all with this solution. It's the only problem, the only downside, drawback is probably it's a little bit lengthy. Okay. But I want you to, if you like mathematics, you need to value different solutions. Because this problem potentially is not an extremely hard problem. So even if I have chosen not a very efficient method to solve, still I was able to solve. But if the nature of the problem itself is somehow is hard, if you don't want to pay attention to these small points, then of course you will be in trouble. Okay, and then how you can understand these things? By solving problems, yes? Okay, so let us start another example. Okay. So if you don't, but still, I just wanted to tell you here, still I have to check, but because I have already checked, I skip that one. So let us go. So let us go to number 3. Let me see which one is good to choose. So number 3, I don't want just to repeat things, but I don't know how much I should go to it because, yeah, hopefully x greater than 1. Okay, this is a very nice problem, but let us see how this will work. But before doing that, by the way, let me write it for you. So this one plus square root of 2 minus x is equal to x minus 4. Okay. We want to solve such an equation. By the way, I hope that I am not disturbing those who actually doesn't like mathematics that much. These are not at the level of the book. But I think if you're interested student, that's fun to see them and making sure that I will not give such questions in the exam, of course. The exam will be at the level of the book. But you see, there is nothing in these problems above your math knowledge. So why not? Why we shouldn't learn that? Why other parts of the world are learning about this, but when it comes here, we want to ignore them, yes? So Let us see them, and of course be relieved that these hard questions are not in the exam. But your math knowledge is exactly at the right level to discuss about these problems. So why not? I hope that you agree with me. If you are against that, you can just tell me. Are you against this?
No, Babak, this is great. Thank you.
Okay, good.
I agree with this stuff.
Okay, so what do you think about this problem? I want to, because I myself was confused when I saw this problem in the notes. I thought that might be this is a catastrophic problem, but I don't think so.
Maybe you can move the root of the 2 minus x to the other side.
Yes, that's one possibility, but let me give you a little bit of hint. If you are experienced here, I can immediately tell you, don't do anything. You cannot find any solution to this equation. You cannot find any number that if you put that number on the left-hand side, of course, real numbers, the number on the left-hand side, the number on the right-hand side, they become equal. Okay?
How do you know this?
Yeah. Do you have any idea? I can help you a little bit to think, but first of all, without any guidance at all. So it means that you should be able to cook up a reason, the argument, to convince everyone that don't waste your precious time. You will never able be to get an answer for this equation without any guidance. Do you know why? If not, I will give you a small hint and then wait.
Maybe it's because in the first root equation, the first root there is x, positive x, and in the second root there is a negative x.
Are you yourself convinced?
No.
Okay. So it means that I cannot also be convinced. Yes. The first thing is in your argument first, the first person you should be convinced yourself first. Yes. But I think you pointed out something good, but not that convincing yet. So you need to work on it.
Okay.
What type of number, first of all, you can fit into this expression? For example, do you think that I can put -2 instead of x? Forget about making the equality right. Just don't look at this for the time being. Do you remember we talked a little bit about domain of a function? This is, if I don't see that right part, this is a function. I can call it f of x equal to this. Do you remember we talked a little bit about the domain of functions? The domain of a function consists of all those numbers that you can put instead of x, and it makes sense. Do you remember? For example, at the very last part of math, so for example, if I give you f of x equals to 1 over x, and if I ask you what is the domain of this function, you would say that I can replace x with any number except one single number that is 0. And then I told you that the domain of f, if you want to write it formally, it becomes the set of x's from the set of real numbers, all real numbers such that x is not equal to 0. Of course, in your book, they have written simply like that, but if you want to write it officially, you write it like this. Anyway, so this means that this is the domain of my function. It means that I am not allowed to put 0, but I am allowed to put any number else. So now, can you just think about what numbers are you allowed to put into this function to make sense? This is a good hint for you now, everyone. We can start again. Can you answer this question? what are the values that I can put into this? For example, can I put 0 there? Does f... No, why?
Because you would get a square root of another
negative 1. 0 is okay for this one because it becomes a square root of 2, which is completely normal. But if I put 0 here, it becomes square root of -1, which doesn't make sense. So for example, 0 doesn't work. What about 4? Do you think 4 will work?
No, it can't be higher than 2 because then you get a negative number in the second root.
Yes, Benjamin. So you are you Benjamin? Yes?
Yes.
Okay, good. You are right. 4 doesn't make any problem with this one. It makes a problem with this one for me. Because if I put 4 here, it becomes a square root of 3, which is completely okay. But if I put 4 here, it becomes a square root of -2, which is not okay. And then my function consists of 2 parts. So if one part is okay, one part is nonsense, the whole thing is nonsense, yes? Okay, so this is a very good hint now. If you look at the values that you can just fit in, let alone the function, let alone the solving equation, forget about solving equation. What are your limitations for the numbers that you can put into this function?
You cannot have anything above 2.
Yes, so it means that the values that I can fit into this function should be at most 2. So it means from above, I am limited. I cannot just go until infinity. The limitation from above is 2. Is there any limitation from below?
Yes, you can't have a number that's smaller than 1.
Yes. So it means that if I want to make sense of it, if I want to make sense of the left-hand side, I have few options. Of course, few options is not good because still I have infinitely many options. How many numbers are there from 1 to 2? Infinitely many. But in a very narrow range. So it means that at least I know that don't look for numbers bigger than 2 and numbers smaller than 1. They cannot make this left-hand side sensible. So how can I make this one, which is not sensible, equal to something else? So this means that this limited me. Now, and let me reveal the right-hand side and start listening to you.
Maybe it's because there are no such numbers between 1 and 2, so it would be equal to x minus 4.
Yes, but we want to say why there is no possibility. That's exactly what we want to convince ourselves of.
It doesn't exist.
So how should you know? How do you know that, for example, something...
There is no such number.
No, come on. 2.5, 1.5, 1.7, 1.69, billions, millions.
There are numbers between 1 and 2, but there are no that are equal to x minus 4.
How do you know that? That's the problem. Did you check all of them in this short time? That is mathematics. You cannot say, no.
It makes sense. I mean, that's why it wouldn't work.
No. How do you know that? You are taking my word as granted and you are saying that there's no solution. But that is exactly, you shouldn't trust me. We want to convince ourselves that even though there are infinitely many numbers that I can put into the left-hand side and make sense, but none of them will be equal to that number minus 4. So your logic is convoluted a little bit. Pardon?
I have an idea.
No, let me finish Rocco's problem first. No, just wait a little bit. So did you understand, Rocco, what was going on? You are saying that I cannot find this answer because I cannot find. This is the way that you are reasoning. You need to say, I cannot find because of these logical arguments. You are saying that I cannot find because I cannot find. Okay, now Gustav, I want to hear from you. Do you have any idea?
I think I know.
Yes. Yeah, you can finish, Rocco, if you want. Otherwise, that is Gustav's turn.
So, can I say?
Yes.
Okay. So if x is between 1 and 2, then x minus 4 will be negative.
That is correct, yeah.
If you're adding these numbers.
Yeah, congratulations. So that is exactly. Because now, because you see that if the left-hand side is supposed to make sense, x has to be somewhere between 1 and 2 inclusive. Just for making this make sense. But unfortunately, if x is between 1 and 2, let us see what happens for x minus 4. If x is less than or equal to 2, x minus 4 is smaller than minus 2, yes? And it's minus 3. So if x is somewhere between 1 and 2, if I subtract 4 units out of it, x minus 4 becomes somewhere between minus 3 and minus 2. So this means that definitely x minus 4 is negative. But this cannot happen because the output of a square root is non-negative. So the left-hand side becomes a non-negative number. The right-hand side is a negative number. Is it possible to force a negative number to be equal to a non-negative number? The answer is no. So it means that don't work, you cannot find any answers. Let me repeat. If you want to make this equality right, definitely the number that might make this equality right, should lie somewhere between 1 and 2. If the number that you choose is not between 1 and 2, the left-hand side is not a number in the first place. Okay? But if x is between 1 and 2, another strange thing happens. If x is somewhere between 1 and 2, I am okay from this side, no worries for the time being. But the problem is that the right-hand side becomes negative. If x is a number between 1 and 2, if I subtract 4 from it, it becomes a negative number. So the right-hand side becomes negative, but the right-hand side cannot be negative because the output of a square root sign is at least 0. So this is at least 0, this is at least 0, so the left-hand side is not negative. So if you choose a number between these two numbers, which you have to choose to make the left-hand side make sense, then the left-hand side is a non-negative number, and the right-hand side is a negative number. So then I realized that this equality cannot hold. So it is not hard at all to convince myself like that there is no root for that. So if you don't believe, you can go to GeoGebra and do this graphing thing. Let me move everything to the left. It becomes minus x plus 4. And then put this in GeoGebra and ask GeoGebra to draw the graph of your function. First of all, you immediately can predict that you will not see any track of graphing outside this interval. So it means that I don't know the graph by heart, but you can see that if this is 1, if this is 2, then your graph will be limited somewhere here. You will not get any graph here. You will not get any graph here. What your graph will show would be somewhere here. I don't know how, but you can probably, if you know calculus later, you can just draw it without GeoGebra, but that's a hard task. I don't want it. But you will see that this graph starts somewhere without cutting the x-axis. It will stop somewhere. Okay? So this is a good exercise to do. So this is a very nice problem. You see, even we don't, but this is a non-standard problem. You see, this is a non-standard problem because the way that you deal with it, it's completely, you need to be very creative, you know, because usually these questions are considered hard because this is completely different from the general strategy of arguing about these. So you see, the way we were solving the problem was just squaring, okay? But every time you need to be very careful. Sometimes you might have a good argument to forego these hard things. So actually, I was a little bit messed up, but because I had experience, so I realized that immediately I can go for it. And I just answered that this is not. But might be, if I change this to x minus 1, then x minus 1 is also non-negative. So this argument will not work. I am in a limbo situation in that case. I don't know if there is a solution. I don't know if there is not a solution. So it means that then I have to follow my general strategy to see which one is correct. But at least for this problem, this is a non-standard problem in mathematics. It will be extremely hard because in the normal way of learning mathematics, we usually learn the general strategies. And that's okay. Any questions regarding to this question? Yeah. So I hope that you enjoyed this problem as well. But let me now go to another problem. We have a little bit of time, so let me go for another problem. Let me see, how do you think here now? Let us go to a harder problem, okay? Do you agree? So 2x plus square root of x, yes, good, to the 4 plus 4 times 2x plus square root of x and then to the 2 is equal to 2. Okay? I really want to hear from you. I really don't believe that you cannot solve these problems unless you don't study with me continuously. Okay? So I would say this is, if, I don't know, according to the book, this problem is not A-level problem. It is A++++ problem somehow, yes? But it doesn't mean that you cannot solve it. I'm completely sure that you have great ideas how to do about this problem. I want to hear from you. If not, I can give you a hint. I just want to wait a little bit. So I don't know. I hope that the numbers are not so bad numbers, hopefully. No idea? Say something. Don't worry about that if this is wrong. Because might be you know.
I had an idea.
Yes, please.
My initial thought was that you take the root out of the entire left-hand side.
How? What do you mean?
You just put a root sign over the entire left-hand side. That would remove the...
Okay, no. That's a crime.
Okay.
No, I want you to understand and promise yourself and me that you will never make this mistake. If a squared plus b squared is c squared, do you see this is a very famous one? Yes, it's in Pythagoras Theorem. Yes. If the method that you are saying is working, why do we write the Pythagoras Theorem in this form? Because in principle you say that I can take a square root, and then I think you want to write a plus b on the left and c on the right. Yes. That I wanted the universe work in this simple way, but unfortunately it's not working. Why is that? Because the square root of a box plus a circle is not equal to a square root of the first one plus a square root of the second one. This is wrong. Be careful, be careful. Promise yourself that you will never make this mistake. Yeah, this is common. Don't think that this is just you.
I will never make this mistake.
Again, yeah, good. But this is very common, very, very common. Okay, don't worry about that. But I'm just highlighting it because I want to make sure that you will never make this mistake. Otherwise, people don't write this Pythagoras theorem in this way because it is much simpler. Why we shouldn't write it like that? Okay. So another idea. Everyone. So yes, that might be helpful. That might be helpful. But then at this level, I have a problem. For this one, I don't have that much problem because this is a squaring pattern. But this is not a squaring. It is a squaring after squaring. Okay? Might be this is the only way. We don't know. This is not guaranteed that the problems are so nice for us to solve them. Mostly problems in the other world is actually formidable. But don't go for this for the first time. Always try to be a little bit lazy, not in the wrong way, you know, because if you are not lazy and you are very stubborn, you can immediately start multiplying this 4 times. Yes? I would recommend you to not to do it, at least if you really run out of all ideas. Yes? At that time, yes, I want to listen to that idea again.
If you move the 2 to the left-hand side, it's a squaring pattern.
Is it?
Yeah, I think so, because the first number equation times 2 times 2 is the second number in the left-hand side.
No, it is not. But that was a good idea. You are coming close. Yes, I am sure.
Okay.
If it was -4, you are right. If it was -4, then if I move it to the right, to the left, it becomes a squaring pattern. But when, of course, you are very, very close now. How did you see that it might be a squaring pattern? Everyone. Just one step, you are not thinking about something. Do you want me to write something?
Please show us something.
Can you see it or not?
Auxiliary variable.
Yes, yes. So do you see if you broaden your point of view, you see that something is repeating itself in this equation. Do you agree? So this is what I want you to understand. I don't want you to memorize. So the people who understand why auxiliary method is useful, if you feel the core of it, there is no way that you cannot understand it here. What was the core of auxiliary variable? if an equation is a little bit complicated, but one part of the equation is repeating itself, instead of trying to work with that hard form of the equation, I can introduce you a name for that part which is repeating itself and rewrite the equation using this new variable. Definitely, this makes the form of my equation simpler. And then, hopefully, I will hope for this, that I can solve that simpler equation. When this is done, when I have my auxiliary variable found, I put it back and try to find my original problem. So this is again the core of auxiliary variable. Now, I don't think that everyone can see that something is repeating itself. Yeah, it is not hard. So I just tell you why you don't succeed to find the method, because might be you haven't understood correctly what is the point of an auxiliary variable. Now, can you introduce me that auxiliary variable here?
Within parentheses,
yes.
2x.
Okay. Okay. But because I am more experienced, I go more than that. But let me stick to Benjamin's method. So you are telling me that let 2x plus square root of x be equal to y.
Now to the power of 2.
Okay, very good, very good. This also is good. But what is there is no downside of it. But if I do this, then this equation, it becomes y to the 4 plus 4y to the 2 plus is equal to 2. Then this is a fourth degree equation. Then I have to bring another auxiliary variable in, and I have to say let us y2 be t, and then I write it t squared plus 4t is equal to 2, and then I know how to solve this problem. So if it is not wrong, but it is tedious, I have to do two auxiliary variables. Okay, so this is why I'm saying that be a little bit practical and lazy when you want to write something down. It is, as Benjamin actually mentioned correctly, it's very good if I take a whole expression to the power of 2 equal to a new variable y. So I would say let this equation, this expression be equal to y. Then what would be the name of this guy? What would be the name of 2 power 4? If the name of power 2 is y, then the name of power 4 would be y squared. And then this equation will be in this form. Instead of this expression, I put y squared. Instead of this expression, I put y, and there is a 4. And this is equal to 2. How many of you can solve this equation? Everyone. This is just a simplest possible E-level problem in this question, in this topic. So this is an advanced problem, but by broadening your point of view, you were able to reduce the problem into a problem that you already know how to solve. This is the whole point of problem solving. Okay, so let us go for it. How much time we have? Let us finish it. I hope that these numbers, the numbers look very, very bad. Yes. Let us see how it goes. So if I want to solve this, and then I will say delta is 4 to power 2 minus 4 times 1 times minus 2. And then this becomes 16. And then how much is this? Yes, it becomes positive 8, and that is the unfortunate thing here, because whenever, I don't know why I have chosen that number. Actually, I'm just taking this from some books. So 24, and this is greater than 0.
Well, where did you get 4 to the power of 2?
4 to the power of 2. This is delta. Delta is b squared minus 4ac.
Okay,
And then b is 4. Yes. And then that I'm just using delta, so it becomes 24. That is a real PT. Okay, anyway. But y becomes equal to minus b plus or minus the square root of delta divided by 2 times a. And this becomes minus b, it's minus 4, plus or minus the square root of 24 divided by 2 times a. But a is 1, so it becomes 2. Yes, I understand. Might be this problem is much harder than I thought because of these bad numbers. But this, I hope that you learned about auxiliary variable in a very good way now. You see, by broadening your perspective, you were able to write this horrible equation into a simple form, okay? And of course, this is a bad luck, but let us see how it goes. I want to teach you a lot of things right now, okay? So here, if you want to work with these horrible numbers, because first of all, you're not allowed to use calculator. Square root of 24 is an irrational number. So whatever you put as decimal points, that's just an approximation. And if it is not mentioned in the problem, they don't expect you to give approximate numbers. They want you to give exact numbers. So you have to work with these bad numbers, I would say. Okay. But first of all, one of them is not acceptable at all. Forget about this. So this is the way that I want you to learn. Don't be scared. I have 2 bad problems. Immediately I can get rid of one of them. I would say that one of them is not acceptable at all. Which one? So let me write here. I have 2 answers. One of them is minus 4 minus the square root of 24 divided by 2. There is another answer, minus 4 positive the square root of 24 divided by 2. Which one I have to throw away? Don't lose track. What is y? Y was not something in the problem. You invented it yourself. You brought it up. You brought it in. What is y? If I ask you what is y, this is the answer. Y is this guy. But this guy is something to power 2. So what can y be negative? No. But this number is definitely negative. Do you agree with me? Minus 4 is negative. The square root of 24, I don't care. It is a little bit smaller than 5. So minus 4 minus a number a little bit smaller than 5, it becomes negative. Divided by 2 is negative. So this number is definitely negative. Let us check here. If this is also negative, we are lucky. We see that there are no solutions, because both of them are negative, but y cannot be negative. But no, this is not the case. The square root of 24 is bigger than 4, is smaller than 5. So it is bigger than 4, positive. Minus 4, definitely this is positive. So it means that this one is not acceptable. I have to deal with just one single number. And then I want you to pay attention to the art of simplification. You can work with this number and suffer a lot, but you can simplify it a little bit so that you can continue. For example, can I simplify this 2 by that minus 4 right now? You see, I am using the same ideas over and over again. Can I simplify this 2 with that minus 4? Let me answer it because there is no time. The answer is no, because minus 4 is a summand of the numerator, not a factor. Okay, so what can I do? I need to be a little bit more creative. Instead of a square root of 24, I can write a square root of, instead of 24, everyone knows that this is 4 times 6. And then what happens for this, I can write it as a square root of 4, square root of 6, but the square root of 4 is just simply 2, so this becomes 2 square root of 6. And then if I go back there, y is minus 4 plus the square root of 24 divided by 2. Oops. Yeah, hopefully it will work. Is it better now?
It's good now.
Okay, good. So it is minus 4 plus 2 square root of 6 divided by 2. And now between these two, I can pull a 2 out. So what happens? This becomes minus 2. This becomes the square root of 6. And then this divided by 2. And now this 2 and that 2 can be cancelled now because this 2 is a factor. So what I get is minus 2 plus square root of 6. And because I'm always optimistic in life, I prefer to see the positive sign first and then the negative sign. But that is just kidding, okay? So a square root of 6 minus 2. So I hope that you agree with me. Working with the square root of 6 minus 2 is more relaxing than working with this number. Even though still it's not a very good number, yes, square root of 6 minus 2. But the problem actually starts from here. So what happens here? This is my y. I have to plug this back and solve the equation. So y is that number, but this is 2x plus the square root of x to the power of 2 is equal to y. Because my goal was not to find y, my goal is still to find x. That's an intermediate variable that I brought in. Okay? Now, let me tell you something. The original problem was this. After all these calculations, I changed my problem to this problem. And hopefully everyone can see that this problem is much simpler than the original problem. So this is not for nothing. We succeeded. We succeeded to make our problem simpler. Okay. And then can you tell me how should I continue now? Might be we will not be able to finish this time, but you can work on it yourself. But what do you suggest to go on? How should I go on?
Maybe take square root of both sides.
Yeah, very good. So because why this shouldn't be hard for you? Take lessons from this. I am completely sure if instead of this nasty number, if this number turns out to be 4, most of you, I would say, you will go for taking the square root sign. Yes? Because you say that this should be 2 or minus 2. But this is what I want you to take a lesson from. When this number, instead of 4, becomes this number, you are lost. Okay, I want you to teach this to yourself. This is not something that I can just warn you about that so you can pay attention to it. Okay, so ask yourself, if you could solve this problem, in principle, this is the same problem. But the number is 4, the number is a little bit more bad-looking number here. Okay, so you are right. I will take a square root. The square root of the left-hand side is this. The square root of this guy would be how much? Would be plus or minus, by the way, square root of 6 minus 2. Okay? And then it means that, again, my problem branches, bifurcates to 2, forks to 2 cases. And I have to consider each one of these cases as before. Okay? Okay, now, can you tell me, I can immediately throw one of them away. Do you see how? And why? Yes, you are right. But let me tell you exactly because exactly like that problem. You remember I was talking about the domain of definition and whatever like that. So the left-hand side considered as a function is not meaningful if x is negative. Yes. So x has to be positive so that this makes sense. But when x is positive, of course, this is the same x that is also positive. So it means that the left-hand side, which is the sum of two positive numbers, is positive. So how is it possible to become negative? So this tells me that forget about the negative one. Okay, so it means that I can just drop this by this argument. You see, this is experience. If you didn't come to this with yourself, you need to take a lesson. You should say, why I couldn't find the answer? Because you had the experience there. Okay, so this way of thinking you need to learn. Okay, and then I go for it. So I will try to solve this equation, which is not, of course, a friendly equation because of this bad number. But that is just a number, okay? So I think we have to stop here. But next time, I want you to work on this problem if you are interested in these kinds of problems, okay? Otherwise, you can just simply ignore that, okay? So let us see how you will solve this problem. This problem is not hard. Can you just immediately tell me what is your first step to solve it?
Square root of x to the other side?
No, I would prefer to move this one to the other side. So if you don't have time, you can leave the lesson, but let me solve this one for you, and then let us see finally what will happen, because I'm myself interested to see how it goes. If I want to solve this is not a square root. Under this square root, there is no x's. I don't need to be worried about this. I need to be worried about that. So I will take a square root of x, and I will take 2x to the left, so it becomes this minus 2x. Then I square it. I get rid of square root signs. Not this square root sign, but this is not important because there is no x behind this. This is problematic for me. So I raise it to power 2. The left-hand side becomes x. The right-hand side is, let me write it in this way, there is no time. So I square it. So this becomes that, and that's a squaring pattern. The first one to the 2 will remove this big one, but it cannot touch this one. Okay? So this becomes square root of 6 minus 2. 2 times the first one times the second one is minus 4 times the square root of 6 minus 2 times x. 2 times the first one times the second one. There are two 2's multiplied together. This is why I have written minus 4. And then this 1 to power 2 is 4x squared. Okay? Okay, so let me clean this. You don't need to be here. If you have something to do, you can leave the lesson, but you can see the recording after that if you want to. Okay, so here, what I do, can you tell me what I do? Is this horrible? Are you scared from this equation? Talk to me. What is the name of this equation? Tell me. Do I need to raise to another power? How many of you agree we have to raise to another power because I want to get rid of the square root signs? How many of you are thinking in this way?
Isn't it a squaring pattern?
No, I mean, how many of you think that still we are not done because there are square roots all over the places? Okay, there is no squaring. Of course, there are square roots all over places, but there is no unknown below that squaring. Might be I was a little bit careless. Yes, these are just numbers. So that's a quadratic equation. Do you agree? So let me keep 4x squared there. And then I move this x to the right, so it becomes negative x. So let me be careful. Minus 4 square root of 6 minus 2. And then I have x. I move x to the left, becomes minus x. And then I have square root of 6 minus 2. Nothing is left is equal to 0. But you see, this is not a standard, because in a standard one, I have one x squared term one x term and one constant number. Here, this is the only squaring term, but here I have two x's. Here, this includes x and this includes x. I want to have one x. So what I do, I take a negative sign. This becomes a little bit technical, I know, but might be this one is good now. And then I have this. So what I have done, if you multiply x back, it becomes x, and this will come exactly this. And then if you multiply this minus sign, I will get this. So I factored an x out. Now, if I ask you, can you solve this problem? Definitely you can. This is a quadratic equation written in a very complex form, but who cares? We know how to solve all of them. A is equal to 4. B is equal to this nasty number here, minus 4 square root of 6 minus 2 plus 1. And then what is C? C is the square root of 6 minus 2. Okay, I agree that this is a hard problem because of these nasty numbers. I don't know why they have chosen these numbers. But I want you to understand, technically, there is nothing hard in this problem. Of course, calculating delta becomes horrible a little bit because I have to raise it to power 2. I don't know. If you are interested, I would recommend. I'm very interested myself, so I will go home and try to solve this problem to see what would be the final number. Is it a very kind number at the end, or I will face hard problems? And I also think a little bit, I will revise my solution a little bit. Might be I can find a better solution. Because you know that when you type an equation, it might happen that you mistype something and they're making life very hard for yourself, okay? But anyway, this, I wouldn't say this is a failure, even though this is probably from pedagogical point of view is horrible, but you learned a lot. You see, might be if I give you this equation, you even don't know where to start with. These are the things that you can immediately learn. Because, for example, when I see this equation, well, how should I interpret that? The first thing that comes to my mind, what type of equation is that? I don't let these numbers distract me. Yes? So what I do, I would say that, okay, I have an x squared. So this is a quadratic equation. But what is the problem with this quadratic equation? The standard quadratic equation has x squared in one place, x in one place, the constant number in one place. Okay, I can give the constant number term to this, and this is just one place. Then this is immediately, it's not hard at all. There are two places involving x. I want to have them in one term. So the first thing that comes to mind is factorization. And then what you happen is that, of course, this number a and this b is a bad number, but that's a number. That's also a number. And then, of course, you need to deal with working with this is hard because if you want to raise it, by the way, this is exactly at the right level. You can manage it, but of course, it's a hard one. I agree with you that this might be a hard problem for you. So if you don't mind, let us stop here. And then if you are interested somehow in the weekend, you can actually work on this problem if you like to. But anyway, next time I will definitely start a new lesson. That was our last lecture about root equations, and I think that was a very informative lecture. You'll learn a lot about non-standard way of thinking in mathematics. Okay, thank you for listening to me and being with me. So I will end this meeting, and I will go to Zoom if anyone is there, if you have any questions.